Hey guys, so in the last two videos, I showed you how to save your data, how to rename it, and then what's actually contained within the data file. So now that we're ready, let's look at how to actually analyze the data in MATLAB. So I created a function called XRF angle scan function version 3. Now you'll notice there's another one here called 2D map. This is essentially the same function as angle scan, except that it's looking at the 2D maps. So the one we're actually interested in for the angles is this one here. So I'm going to walk you through what the function actually does and then how you can actually use it. So, okay. You'll notice first, what are the inputs that the sample needs, that the function needs? First is the sample name, which is going to be what we showed you here. The total number of runs or the total number of measurements. So here 0, 1 to 0, 16. So this value would be 16. The start time. Now the start time is the time at which you started the electrochemistry experiment. So what I forgot to mention in my last video about data is that with each file or sample, we have a concurrent electrochemistry data file. So you'll see if I open this here, this is the echem data that we're recording at the same time that we're doing our XRF. And you'll notice here that there's a thing called real time, and then you have a value here. So here it's 7:51 a.m. Now, as a quick note, the computer that we used when we went to Saskatoon was not properly set. So this time, although it showed here 7:51, it was actually 6:51 because there's an hour delay or there's a time zone change. So I'm going to have to use a time of 6:51 when I run this function. So if I go back to my function, okay, and then the limits, in order to be able to plot everything and to compare it properly, we want to make sure that the limits of all the plots are the same so we can see how the line is changing over time. At the beginning, you can leave this to sort of the value that's already in the file, but then as you go on, you'll realize how to change those files. Okay, so how does the function actually work? First off, because we want to do this analysis on several data files, so I'm just going to go back here for a second. So we have 16 files, so we're going to rerun the whole function 16 times. That's all this is doing. Now, first line of code. MATLAB reads numbers without zeros beforehand usually. So in other words, sample 1 would literally be sample 1. But you'll notice that in the file it's called 01. So this first line of code, all it does is it adds a number 0 before the data file. Now, one really important thing, you'll notice here that the function automatically adds underscore angle underscore 0 or underscore the number of the function. This means that your file name when you're doing angle scans always has to contain at the end underscore ang underscore the number. That's how MATLAB reads these files. Okay, so that's for this part. Then raw equals import data. So it's using the file name and it's adding the extension by itself. So again, you don't have to put the extension for the file name. That'll make sense in a minute. Sometimes when we open these files, you'll notice that there are some empty lines. So what this line of code is doing is it's just telling MATLAB, ignore the empty lines here. Okay? Now, data equals raw.data. What this means is MATLAB actually exports all of these things, the text and the data into separate, or the numbers into one array. So what this line of code is saying is give me just the numbers. So now I have this one matrix containing all the numbers that you can see here. Okay. Now, we inputted the time that we started our electrochemistry, but we also want to know at what time we started our XRF measurement. So if we go back to this data file, you'll notice here it says date and then it has a time. So what this line is doing is it's basically figuring out what time, so hour, minutes, and seconds, was this measurement done. That's all this whole block of code is doing. Okay? Now, extracting the data. If I go back to this whole block of numbers, what we actually want is, as you can see, column 1, 15, 17, 19, and 21. Okay, so basically the data that we actually want is column 1, 15, 17, 19, and 21. Okay, now in this file here, I'm showing you arsenic first and then iron second. Sometimes there's a bug in the Synchrotron software, and so these will be inverted, so you'll see iron first. So what this first line of code is doing, element 1, is it's figuring out, am I actually reading the iron or am I reading the arsenic? So this should take care of that problem. And it'll reorder everything to make sure that the data is always in the same order. You see, it's always in this order here. Angle, iron K alpha, iron K beta, arsenic K alpha, arsenic K beta, and then it also adds the ratio of the two. So after this point, the data will always be in this order. Okay? Now that I have my data file in the correct order, I can simply plot everything on the same figure. So in the first plot, we're going to have iron K alpha, then we're going to have iron K beta, the ratio of arsenic over iron for K alpha, then we're going to repeat the same thing for the K beta. These 6 lines just add the colors to the plots just to make sure that we have all the same color. This here sets the limits for the plot. So this is to make sure that the plots are always on the same X and Y limits. Adding some titles to the axes, so the beam angle and the normalized intensity. Setting the name for the ratio, so we have a legend also. Okay, this last one here adds some of the important information to the plot. So the time is how much time has elapsed since we started our electrochemistry. What is the energy that we use? So that's actually this number right here, 13705. What is the sample name? So that's the sample that we inputted. And then what is the scan or run number? So what measurement? For example, are we showing you 6, 7, and so on? Okay. That creates a new figure, and then it saves the figure with the same file name as a JPEG. It'll also show you some information, but that's not really that important for when we're doing our measurements. And it'll repeat this for every single data point that we have. Now, this is showing you for every measurement all the angles. But what we want to do is compare the values over time for the angles. Now, because it would be kind of hard to see on a plot all the different angles, what we're going to do is we're going to look only at 0 degrees and at 60 degrees. So here we're just remaking our data file to show 60 degrees and 0 degrees. And then we're going to, instead of plotting intensity versus angle, we're actually going to put intensity versus time. So these plots here will just plot the entire data set over time. And this is the same as before. So here we're just adding colors, limits, titles. So this is just basic MATLAB plotting commands that are not really essential to analyze the synchrotron data. We're also adding, again, the information that we want. And then we're calling this file by the sample name and ending with time comparison. And then, because sometimes it takes a long time to analyze the data, I added a little noise at the end to let you know that it's finished, so it sounds like a bird chirp. So in the next video, I'm going to show you how to actually run this function.